Okay, looking at 646 here. What method is the best method for solving this, do you think?
Equal values.
Yes. Equal values method, which is pretty much just substitution. So we're going to substitute here. Do 3x plus 7 equals negative 4x plus 21. Add 4x to both sides. Subtract the 7 from both sides. 7x equals 14. X equals 2. Now we can plug that back in to maybe this top equation. Y equals 3 times 2 plus 7, which y equals 13. Okay, what method's the best one for here, Zoe? Elimination. So since we can add these up, we already have coefficients that are opposites here. So we can just go ahead and eliminate that by adding down. 3x plus negative x is a 2x equals 17 minus 7, or plus a negative 7 is 10. X equals 5. Substitute that back in. I'll use a second equation this time. Negative 5 plus y equals negative 7. Add 5 to both sides. Y equals negative 2. Don't forget on the test to make sure that you solve for both x and y. Don't make that mistake that you did on the quiz. Okay, 146C, which method would be the best there? Substitution. I would say, because it's already in x equals form right there. So we can substitute that in for that x. 2 times 3y minus 5 plus 12y equals negative 4. 6y minus 10 plus 12y equals negative 4. Combine like terms. And you guys are pretty good at this too. You probably could do this all in one step. I'm going to combine like terms and add the 10 to both sides. Ooh, I got a fraction. Did you guys get fractions?
Yeah. 1/3.
So y equals 1/3. I still need to find x. Don't mess up on the test with that. On the quiz, a lot of you did that where you only solve for one variable. You know x now equals 3 times y minus 5, and y is 1/3.
Is it just a coincidence that one of the equations equals negative 4?
I think it's okay. Yeah, it's a coincidence. There you go. So x equals negative 4, y equals 1/3. Bob climbed down a ladder from his roof while Roy climbed up another ladder next to Bob's ladder. Each ladder has 30 rungs. So Bob went down 2 rungs every second. I'll just use Bob's here. What Bob did is he went down 2 rungs every second. So he actually started at 30 rungs. And since he's going down 2 rungs per second, he went minus 2x. X is seconds. Roy, on the other hand, he started on the ground, so height of 0, and he's going up 1 rung every second. And you want to figure out when they're the same height. So even though I use a B and an R, they both have that same distance they're going to be traveling. So I can go equal values. Add 2x to both sides. 30 equals 3x. X equals 10. So that is when they were the same height. after 10 seconds. They're the same height. And what rung are they on? They're on their 10th rung because I could plug a 10 back in here. He went up 10, Roy would go up 10 rungs, or Bob would go down 20 rungs to the 10th rung. A here, we can subtract the 4x from both sides to get 2x. Add the 11 to both sides to get 23. Divide by 2, get a little bit of decimal. X equals 11.5. You okay with that? Okay, so on B here, we would start by distributing. So I'll rewrite it up here. 6x minus 10 equals 6x minus 4. I'm already seeing an issue here. I see I have 6x's right there. So what's going to happen is when I subtract 6x from both sides,
No solution.
exactly, I end up with negative 10 equals negative 4, which is not true. So that means the answer is no solution. Nothing will work. To start off C, you got to use FOIL or distribution. Just make sure, a lot of people make the mistake where they say, oh, that's x squared minus 12.
No.
And that's not right. You have to make sure you multiply everything. That's x squared plus 4x minus 3x minus 12 equals x squared plus 4. Now right now, if we didn't have the x squareds on both sides, we might be in a little bit of trouble. Because we haven't gone over how to solve with x squareds yet. But right now, if I subtract the x squared from both sides, yeah, they cancel out. And I can combine these for an x. Minus 12 equals 4. X equals 16. All right, on D, you can cross multiply. There's two ways you can actually do this. One way is you can cross multiply and make equations that way. So you have 10x equals 25 times 7, which is 175. That's one idea. Divide by 10, divide by 10, x equals 17.5. Another way, like Chase just said, is this is 70%. So if you figure out what 70% of 25 is, I'll use that as a different method. So 7/10 equals 70%. So if I do 70% times 25, that gives you 17.5. That's another way. That's a less algebraic way, but that's okay.
What did we get for C?
Hold on one second. The last way, another way you could do it, and this is kind of the same way we did E, but this way will also work, is you can find a common denominator. This is a little bit more work, but you can always think of common denominator here as 100. Okay? So you can do a common denominator, which would be this times 4 over 4, and that times 10 over 10. Actually, I see 50 would have worked probably better.
Yeah.
But we still get 4x over 100 equals 70 over 100. And if we multiply both sides by 100 now, those cancel. So you get 4x equals 70, which means x equals another 17.5. So there's a lot of ways you could do that problem. Okay, so looking at E here, we have fractions, which is never nice usually. No one loves fractions.
I like to challenge myself.
You like to challenge yourself? I'm sure that happens a lot. So, what's my common denominator that I want to use there?
12.
Get rid of the fractions. So you multiply both sides by 12. So if I multiply everything, both sides, by 12 and distribute, 12 times 2 is 24, divided by 3 is 8. X. 12 times 3 is 36. 12 times a fourth would be 3. X. And 12 times 7 is 84. Now, once we have it in that form, should be much better. And you guys are pretty good at this by now. We can do it all in one step. Subtract the 3x from both sides. Subtract the 36 from both sides. So now you get 5x equals 8 there. Oh, wait, that's wrong. Yeah, it's a negative. So that would be 10, negative 120. Divide by 5. X equals negative 24. Okay, looking at F here. What can I multiply everything by to get rid of that? You could do 12. Could you do anything else?
3.
You could just do 3. You could do 12 or 3, either way. Why not? Let's try both ways.
3 first.
Pi times 3 would give you a 3x. And then when I multiply 3 times x over 3, it would just be x. So plus x equals 12. 4x equals 12. X equals 3. If I multiply it by 12 instead, I would have 12x when I distribute here, plus 12x over 3 would be 4x, equals, and then 12 times 4 here is 48. 16x equals 48. X also equals 3. Anything that 3 goes into would be, yeah, both ways work. The 3 is easier, I think, but either way will work. Zoe.
You can just multiply the x by 3. By 3 over 3.
You can multiply the x by 3 over 3 to get rid of it. That would also work.
Also use this one.
Yes. So we have t equals an plus b. We want to solve for b. We only need one move to solve for b. What move is that? Subtract the an. So t minus an equals b. Done. So we're just solving this question for y. So I'm going to rewrite it. Y over 3 minus a equals b. I want to get y by itself. So here's y. It's attached to this divided by 3 here. So I want to get rid of this a first. So I have to add that to both sides. So I get y over 3 equals b plus a. You could have a plus b too. It doesn't really matter. Addition's commutative, so it can be either way. And now we have that divided by 3 we want to get rid of.
Yeah.
So we need to do what? Multiply by 3 on both sides. Just make sure you multiply the whole side by 3. And a lot of times we rewrite it. I mean, I would imagine the answer in the back of the book, if you had saw it, would probably have the 3 out in front of these parentheses. And a lot of times they put this in alphabetical order. But you could have had it the other way too, and that's fine. Questions there? Okay, so a question we had here is, can we multiply the whole equation by 3 first? And we can. It's going to be a little bit more messy, but let's see what happens. If I take y over 3 minus a equals
I meant just like
b.
multiplying by 3 first. So like y over 3 is you just multiply.
Right, we have to multiply the whole thing by 3 is what you're saying.
He's just
Okay.
writing it out.
I'm just writing it out here. So but the thing is, you got to multiply everything by 3. So that would mean that when I distribute here, I would get 3y over 3, which is y,
Minus 3.
minus 3a
Equals 3b.
equals 3b.
That's what I did.
Yeah, you could do that.
Okay.
That's what high got.
Y equals 3a plus 3b.
So whenever you just multiply like fractions or something like that, you just have to do it with the whole.
You have to do it the whole side. And both those are right. Notice if I distribute this left side, it works. On C, we have f equals ma. How would we solve that for m?
Divided by A.
Divide by a. M equals f over a. On D, we have f equals ma again, and we want to solve for a now, so what do we do?
Divided by M. A equals F.
Last question was, does anyone know what that stands for? F equals ma. It is an equation. Jackson.
Force equals mass times acceleration.
Perfect. Force equals mass times acceleration. You'll be using that in science. Probably physics. Okay, this is 150. Leo solved a system of equations by graphing his graph is shown at the right. Estimate the solution from the graph. So let's zoom in real quick here. What do you think the solution here is for this graph? Make a good guess. Where is the solution for this graph? Skylar. At the intersection, right there. So let's get a good estimate of what that would be. 2.5.
1 and a third.
1 and
1.3 and like 2.2.
I like 1.3
That's what I guess.
and 2.3. Okay. Of course, I didn't leave myself enough room. Let's do this. 1.3, 2.3. I'm okay with that. Okay. What is the equation for each line in the system? So let's zoom in a little bit here. B says, what's the equation for each line? So if I look at this line right here, what's the y-intercept? 1. So I know I have a y equals something x plus 1. Yeah, if I look at that point over here, I can see the slope here is going up 1 over 1, up 1 over 1. Y equals x plus 1 for that line. Okay? The other line, what's the y-intercept? 5. So we got a y equals plus 5 here. And what's the slope?
Negative.
Yeah, it looks like it's going down 2 over 1, down 2 over 1. So we negative 2x plus 5. Solve the system algebraically. Okay, well, now we have two equations. We have a y equals x plus 1 and a y equals negative 2x plus 5. What's the best way to solve that system?
Equal values.
Equal values, or you call it substitution, but we could just, they're both equal to x, or to y. So we could do negative 2x plus 5 equals x plus 1. We can solve these. Let's go subtract. Let's go actually, I want to add the x to both sides, 2x, so that way it's positive. Subtract the 1. So I get 3x here equals 4. So I can divide by 3. So x equals 1 1/3, which is pretty close to our 1.3 here we used. And I can substitute that back into this one, which means that y would equal 1 1/3 plus 1, or 2 1/3. And that's pretty close to 2.3. So I think we did a decent job. It's a good estimate. On 51 here, as a treasurer of his school's FFA club, Kenny wants to buy gifts for all 18 members. Okay, he can buy t-shirts for $9 and sweatshirts for $15. There's 18 members, and the club has $180. If Kenny wants to spend all of the club's money, how many of each type of gift can he buy? Okay, so there's two equations that you're going to write, a system of equations. The first one that I always see, because there's a lot more information in the problem, and it's usually not how the book shows, but I see a lot of money stuff going on here. So my first equation is usually the equation that deals with the money. So I will say, I see $9 for a t-shirt. So I can say 9 times t. That's going to be the amount of money spent on a t-shirt total, plus 15s. That's the amount of money spent on sweatshirts. And how much did they spend total? 180. So that's my money equation. Looking at your guys' work, I think that that's the equation you guys find the quickest. Now the second one is always kind of the it's so easy it's hard equation. But I see that 18. How am I going to use that 18, Kira? 18 equals something. I agree with that. Steven?
You're gonna put it equals to the amount of t-shirts that people are buying, T and S.
Yeah, so T is the amount of people, the t-shirts they buy. And S is the number of sweatshirts. And we're assuming, I guess, that every person only gets one. That's a big assumption here. Nobody's going to get both, and everybody's going to get at least one. So that means your t-shirts plus your sweatshirts have to equal 18. All right? So you have your system of equations here. And what's the best way to solve this, Aiden?
Can't you just multiply the bottom one by 10 and then...
Not 10.
Yeah, because 180 and 180 are equal.
You could multiply the top by 10, the problem, or the bottom one by 10. The problem here is if you multiply this by 10, the whole point of elimination is to eliminate a variable. And you're not going to get any elimination on your variables. You're going to get elimination.
Equal values. So
You want to eliminate a variable.
But you'd still have a T and an S on both sides.
You have both.
So you're saying, you're right. You're saying that, what Aiden's saying is if I multiply this by 10, I'll get 180, or negative 10 maybe. And then I can set, because they're both equal to 180, or just actually positive 10, then set them equal to each other, but then I'll have 9t plus 15s equals something with t and s, and I didn't get rid of any equation. So what do you want to multiply by, Kira? 15? Positive 15 or negative 15? And then you subtracted? Okay, so you're going to multiply by 15. Let's do that way then.
Why are we doing it by elimination? Wouldn't it
Yeah,
be easier just
I
to
think so.
subtract the s or subtract the t, and then you would just have your answer?
Okay, so you do have two ways here. You could either eliminate by multiplying this by 15 or negative 15 or 9 or negative 9 and subtract. I do slightly agree though that, 15 wouldn't be too difficult if I had a calculator. I could do 18 times 15 pretty easily. But we're also saying another way you can do it is just solve this for t or s and then substitute. All right, that's what you're saying, Eric?
Yeah.
Okay. What way do you want to do it? Raise your hand if you want to eliminate here. Raise your hand if you want to substitute here. Okay, we'll substitute then. So let's go. So this is going to actually, you guys could probably do this in your head. I'll just do t equals 18 minus s. One thing I do sometimes with my s's, I'll put a little cross through there. So that way I know it's an s. Otherwise I'll mistake it for a 5 if my handwriting's poor. And then I could substitute that in to the first equation.
You plug it in for
So we'll get 9 times 18 minus s plus 15s equals 180. All right, what's 9 times 18?
162.
162 minus 9s plus 15s equals 180. And then we have a minus 162 from both sides. I can combine the negative 9 and the 15 here. So that would be a 6s equals 18. So s equals 3. So the 3 sweatshirts. Now their total here was 18. Or I can plug it in there. 18 minus 3 is 15. So t equals 15. So there's your system. Questions there? Okay, on 152, we have a sequence that's been graphed already. So I'm looking at my graph over here, and I can see these points of the sequence. So the first thing I would do is to put them in a t-table. So 1, 6, 218, 354. The first question, A, is what is the multiplier for the sequence? So what are you multiplying there by each time? 3 times 3. So your multiplier is 3. Then the question is write an explicit equation for this sequence. Okay, first question is what kind of sequence is this? Anyone remember from last semester? Geometric. So this is a geometric sequence because you're multiplying each time. Now, does anybody remember how to write the general explicit equation? Logan.
Isn't it like t of n equals 3 of n plus?
Well, this is general. So you're putting numbers in there.
A
I like
times b squared, a times b to the nth power.
a times b to the nth. What were you going to say?
I was gonna say it would be like t times n equals the 0th term times like whatever it's multiplying by to the n power.
Perfect. All those are right. So there are two ways I want to look at it. One way is graphically. When I look at a graph, usually I think of y equals form. I think of it as y times a times b to the x power. The other way is more of a sequence form. And a lot of you guys said it, which is t sub n equals, and then usually you write t of 0, which is the 0th term, times your multiplier up to the n power. And we've used a couple different variables for these two things, but that's the idea, okay? So the first thing we need, no matter what, right here is the a or the t sub 0, which is your 0th power or 0th term. What would be the 0 term that goes here? 2. So 0, 2 would be your 0 term, which means your 2 would be here or here for a. Okay, so we would have t sub n equals 2 times, and it's the multiplier, which is 3 to the nth power, and that's your explicit. Or you can write it y equals 2 times 3 to the x. Usually I write it like this when I'm thinking about graphs. You write it the same one on the left when you're thinking about sequences, but it's the same idea, just different variables. Okay, and then C says write a recursive. So this is explicit for B. For the recursive, you need the same thing. Usually you need a starting point, and it doesn't really matter which starting point you use. You can use any one of these. This is A sub 1, or actually T sub 1, T sub 2, T sub 3. You could even use T sub 0 if you want, but usually we start at 1 when we're talking about sequences. So you would just write down T sub 1 equals 6, and then you have to do a little bit of yuckiness with some notation. But the way you write it is t sub n plus 1, which just means the next term, equals the current term, which is t sub n. So it always has that look to it. And what are you doing to each term right there? Multiplying by 3. So just put a 3 times t sub n. And that's your recursive right there. All right, this one, 153. In 2012, the average cost of a new mid-sized car was about $31,000. New car prices tend to go up by 2% every year. Okay, so if we wanted to figure out what the new price was in 2013, what would we do? Steven?
Find what it's gonna move up by every single time.
So how would you do that? What are you going to multiply it by? Tyler? Or Dominic? Sorry.
1.02.
1.02. So if I want to figure out 2013,
Yes. Say yes.
I would take 31,000 times 1.02. Ashley?
Why 1.02?
Because 2% is 0.02, but that's only going to give you the percent of increase, and I want to add that to the original, so by including this 1.02, it includes that original. So that's how I would figure out 2013. So my multiplier is 1.02. If this trend continues, what will be the cost in 4 years? You could, I guess, easily just start at 2012. Let's do that.
Wait, Mr.
Yes.
After I did this, I looked in the book, and it in the answers place in the book, it actually it kind of did the equation in B and then it solved for 4.
Okay.
And so it was kind of weird.
So it's asking you for the equation. It used the equation to solve for it, and then it asks you for the equation in C.
Yeah.
You don't have to use the equation. I mean, if it just asked me to, I would probably use the equation, but if you're not comfortable, use your multiplier. So 2013, 2014, 2015. So that would be 1, 2, 3, 4. So in 2016, I can just multiply that by 1.02 4 times. So that would be 33,555. If you just take that 31,000 and multiply it by 1.02 4 times. Now we need an equation. Your equation is, if you think about it, every year you're multiplying your starting amount by 1.02. When you're multiplying, this is a geometric sequence. This is what we worked on before. So if you think about it, we can just take our starting amount, which would be 31,000 starting amount in 2012 times 1.02 up to the n power for n years. And we could just say like a of n. And what that's going to give us, that gives us the n is the years since 2012. So 2012 is our starting point. So if you want 2016, you have to plug a 4 in and it should work there. Questions on that?